Hello everyone and welcome to another episode of GDDV 106 Development Concepts. My name is Kasanis. Guys, we're moving along pretty well here. I know we're covering some topics that some of you might not be super comfortable with. The idea of coding might still scare you, but actually I think we're doing pretty well as far as our pacing is concerned. So we've already covered the course introduction and the introduction to the Unity interface. Great. And we moved on to scripting. So far we're going pretty easily. We've talked about the idea of object-oriented programming language, the fact that C# utilizes classes and all of your code have to be located in a class. We talked about what a class is, and we've also talked about the idea of variables and the idea of primitive data types and data types. So that's pretty great. Now we're going to move on to the idea of functions. So we talked about what is a class. Now we're going to talk about what a class can do through its functions. All right, everyone? Let's get started. So functions. We're going to talk a little bit about functions, and we've already talked about the idea of the variables in a class being able to define the class, being able to define aspects of that particular class. But it's the actual functions that really define what a class can do. If there is not a function associated with a particular thing you want to happen, well, that particular thing can't actually happen. Without a function, the class can't do whatever it is you want to do. So we talked already a little bit about the start function. We looked at it in the last episode when we utilized the start function to really display some of the initializations of our variables. So we kind of went over the start function briefly, and we'll go over it a little more heavily in a second. But today I'd like to examine a number of functions. I want to talk about the start function again, but we're also going to talk about the awake, the update, the fixed update, the late update, and finally custom functions. We're going to cover all of those things today. Let's talk a little bit about the awake and the start function. We'll do a comparison between the two. A lot of people confuse these and they don't really understand exactly how they work. The start function is the script that we saw in the last episode, and we saw that as the start function ran, we utilized it to show off some of our initializations through print statements and debug statements. And basically, the start function will run when a script is first enabled. That's when a start function will run. If a script is not enabled, if it's disabled for some reason, then the start function itself will not run. Now, the start function is a great place to do initializations of the objects, variables. It is a great place to call initial functions that might be required in order to set up the object properly. It's a great place basically for initialization. Now, the awake function is very similar in the fact that it is also called towards the beginning. It's actually the first thing that's called. The awake function is called before the start function always. Now, where the start function is called upon a script becoming enabled, the awake function is called immediately upon the script being loaded. So as soon as the script is loaded, the awake function will be called. And the start function is called only once the script is enabled. That's the difference in the two. So the awake function will always be called first, and then afterwards, whenever the script becomes enabled, the start function will be called. Okay, so let's head back into Unity now and check out both the start and the awake functions. Okay guys, here we are inside of Unity, and we're using the exact same project that we were utilizing in the last video. Nothing's really changed. I've still got my main camera, my declaration, variables game object, and my example game object that doesn't do anything. Let's open up our variable declaration script and examine the awake and the start functions. So this script hasn't changed at all. All I'm doing is declaring a bunch of variables at the top, and then we finally come along to our awake function. Now let's take a look at how this function operates. It operates exactly the same way as every other function. It has the same format as far as every other function is concerned. We've got ourselves the accessibility. This is a private function. Functions can be either private or they can be public. We've got our return type, which in this particular case is void, and we've got the name of the function. In this particular case, it's called awake. Now after the name of the function, we've got ourselves parentheses, and these parentheses will include if there are any type of input variables that go into this particular function, they'll be included here. So in this particular case, there is nothing that's coming into this function. It's nothing at all coming in. All we're doing in this particular function, in the awake function, is we're printing out this is the start of the awake function. That's it. And that's going to give us in the console a particular time and demonstrate to us exactly when the awake function is actually in operation. Now, the start function similarly created, is going to be, it's by default, it's private as well. Similarly, it's going to work it's going to work very similarly. The print statement is going to tell us this is the start of the start function. So then we're going to see when the wake function runs and when the start function runs. Okay? So let's head back into Unity and check it out. I'm going to close this off. Here we are inside of Unity with a clear console, and I'm going to hit play. Okay, there we go. And we can see this is the start of the awake function. And it occurred at 13:51:59. That's when I'm recording. And it says here, this is the start of the start function. It occurred at the same time, but the awake function ran first and the start function ran second. It's because I can only see seconds on here. I'm not seeing fractions of a second. So the awake function ran first, the start function second. Let's stop it and test it again. What if that was just a fluke, right? Let's clear this and hit play one more time. Okay, there we go. This is the start of the awake function. This is the start of the start function. The awake function will run before the start function every single time. Now, as I've mentioned, let's turn this off. As I've already mentioned, the awake function will run as soon as the script is loaded. The start function only runs whenever the script becomes enabled. So here's what I'm going to do. Let's test that out. I'm going to come over here to my declaration script, my variable declaration script, and I'm going to disable the script. I'm going to clear my console, and I'm going to run it one more time, and let's see what happens. Bang. There we go. The only thing I'm seeing is this is the start of the awake function. Now watch what happens when I enable this script. Enabled. Immediately the start function runs. So the start function is available to us only when the script becomes enabled. All right, guys, let's head back to the lecture. Okay, so that is the awake and the start function. Let's now take a look at the update, the fixed update, and the late update functions. So we've already seen that whenever we create ourselves a new script, Unity automatically provides for us a start function and an update function. The update function and the start function are both blank. That's how they come in. They come in blank. We have our parentheses. We've got our brackets that define the scope, but there's nothing included inside of that scope. So it's up to us to fill it in. The update function is called once per frame, every frame. That's its job. Every single frame, all the code contained within the scope of the update function is run. Every single frame. If you are outputting 60 frames per second, then your code will run 60 times per second. If your computer is operating at 10 frames per second, well, then your code will operate 10 times in every second. So there's a potential issue whenever we're using update, and we have to consider it. Whenever you add anything to your update, you may be running code unnecessarily. Really consider what you're putting in your update and why. And if you have something that's dependent on the update, that's frame rate dependent, things could change. If you were running something and let's say you were changing the color of your screen and you set it up so that every frame the color of your screen changed, well, if you have a monster computer, you might be running that 1,000 times per second. You'll have this strobing color effect that I don't think you'd see because I don't think the refresh rate of your screen is fast enough. And if you have running at a slower rate, then obviously you'd have a much slower update that's occurring. So this is something we really have to consider. That's a potential issue that you could have when using the update. Remember, your code is run once a frame, every single frame. The late update is very similar to the update in so much as it's run every single frame. However, the late update is run once all of the code in the update has been completed. So the update runs, then afterwards the late update will run. So again, we have exactly the same problem. It is frame rate dependent. Any of the code you put in here is run once a frame, every single frame. The last thing I want to talk about here is the fixed update. The fixed update is similar in nature to the update and the late update. However, the fixed update is called at a particular interval. It's called after the physics update. So the fixed update is frame rate independent, which is great. If you have something that you want to run at a particular amount of time and ignore how quick the computer is able to do so, you can do so utilizing the fixed update. And the fact that it runs after the physics means that it'll take into account any physics you have. It's not going to work against the physics. It'll work with the physics engine. You can change what the update rate, the fixed update interval is. By default, the fixed update interval is set to 0.02 seconds, but you can change that value by going to your edit, project settings, fixed time step. We'll take a look at that in 1 second. So let's head back into the project and see the results of the update, the late update, and the fixed update. Okay guys, here we are back inside of Unity, and all I'm going to do is hit play. And let's take a look at what's happening here. Right away we can see that our thing is scrolling all the way up. If I scroll all the way down, we can see our numbers counting up, and that's exactly what we're expecting to happen. I'm going to hit stop here, and let's take a look at what happened. Our late update value is 625, our update value is 625, but our fixed update is only 368. So we can see that every single frame, our update has been running, our late update has been running. They are equal in every way. They're equivalent because the late update runs after the update has, but our fixed update, which is running on a time interval, does not have the same value. Okay? Because it's running at a specific time and is frame rate independent, our fixed update value is lower than that of our update and our late update. Okay, awesome. Let's head back to the lecture and keep going. Okay, so the last thing I want to talk about today is the idea of custom functions. If all we had to work with was our start and our awake and our update, well, we'd be in some trouble, right? So custom functions allow us to add customizable code and certain things that we want to actually happen as custom functions. Custom functions are defined in exactly the same way that the other functions were defined. They take on the following format: a type, so the accessibility, private or public; a return type, what's being returned from the function name, the parameters that are going into the function, and braces that encompass our function code. And the function code is the meat of whatever it is you're trying to do. So let's take a look at this. A type is either public or private, and it's private by default. So if you don't put anything in for the type, it's automatically private. You have to explicitly say this is a public function in order to make it public. The great thing about a public function is it is visible to other classes. Other classes can actually run this function. So if you've got yourself another class, let's say you're creating a health system, and you've got a sword, and every time that sword hits your player, you want to be able to call the do damage function, right? The do damage function is going to automatically subtract the health from your player. Well, whenever the sword hits the player, you want it to be able to call that do damage function. So by making the do damage function into a public function, it's going to allow the other classes to actually call it. So the sword can call it, the bow can call it, or whatever else it is that's doing damage can actually call on the do damage function. And we're going to explore this. Later on, we're going to take a look at the idea of creating pickups and things like that, and we're going to use public functions for that. A private function is much more protected. So within your function that you've created on your initial class, let's say class A, you've created a particular function, and class A has a variable, let's say health, that you are tracking in class A. If you don't want any other class to be able to immediately adjust the health value, well, then you're going to want to make sure that any way that they have to adjust the health value is private, right? So if another class comes in and you want them to be able to only read the health, as an example, well, you're going to make it what's called an accessor function to be able to return the value of the health but not actually manipulate it. So a private function is going to be a little bit more protected than a public one is. The return type, functions can pretty much return anything you want. You're going to want to return something from a function. Let's say that just an example I have, let's say that every time you want to query how much gold you have in your inventory, you have a function called query gold, and it can automatically have a return type of integers that returns the number of gold coins you have in your inventory, as an example, right? So the return type is what is being returned from the function. When the function is finished running, this value or this thing is then returned to whatever called it. Okay, if you leave it as void, void means don't return anything at all. So nothing is returned from a void function. Okay, and all the functions we've seen up until now have been void functions. It was a void start, void update, void fixed update, etc. After that, we have our function name, and that's just the name you've given your function. Try and give it a good name, guys. Try not to call it like function X or something like that. Give it a name of what you want it to do damage, or add health, or make gold, or whatever it is that you want to do. Give it a good name. Make sure people understand what your function is doing just based on the name by itself. After that, we've got ourselves a parameters list, and our parameters list is a number of parameters that are feeding into the function, and the function can utilize those parameters, those variables, in its calculations within its function code. Lastly, the function code is located within the body of the function itself, so it's the actual meat. It's where everything happens, and function code is just code that does something, adds health or adds gold or whatever it is you're doing, that's what it does. Only the code that's located within the scope of the function is going to operate within this function. So again, we've got ourselves curly braces to define the scope of the function. So a couple things to note. Variables that you've declared in your class are available to all of the class functions. That means that if you've got yourself, whether they're private or they're public, any of the variables that you've declared within your class are going to be available inside of the function itself. Also important to note that if you declare new variables inside of your functions, inside of your custom functions, if you've declared variables inside of that, those variables are only visible within the scope of that function. So if you create yourself a new int, you've declared yourself a new int inside of a function, that int is only available inside of that function and will not be visible outside of it. And lastly, you are not able to declare any kind of public variables inside of a function. You can only declare your public variables at the top of your class. Okay, so with all of that said, let's head back into our project one more time and let's check out the use of functions. Okay guys, here we are back in our script, and I've made a couple of quick adjustments for you just so we can see this operational. We still have our myInteger equals 8 up here at the top. It's still public, so we can adjust that value. Let's scroll down here. What I did do is I removed the subtraction that originally occurred. So myInteger is 8. It's no longer subtracting anything. It starts off as 8. What I've done is I've gone in and I've printed the integer value. Afterwards, I have used what's called the integer doubler. This is a custom function that I wrote. It accepts a value, and it returns that value into myInteger. So it sets myInteger equal to something new. So afterwards, I then print out what myInteger is now. It should start off as 8. It should get doubled, and then it should become 16. That's what we should see inside of the actual code. Let's scroll down here and take a look at the integer doubler function. Here's our integer doubler function, and it takes the same format that we already talked about. It is a private function, so I don't have to declare it as such. It's automatically private. It returns an integer. It is called integer doubler. It has a parameter list, an integer value of x, and all it does is it comes in and it says x is equal to x times 2. So it's doubling the value of x, and it is returning that value. That's all it's doing. And when it does so, it's returning it and setting it equal to the myInteger value that we started off with. Okay, so let me just file save this to make sure that it's operational. Let's head in here to Unity, clear this out, clear, and hit play. Let's see what we got going on here. So here's our awake and our start function. MyInteger is 8. MyInteger is now 16. Okay, so that's exactly what we wanted to see. MyInteger is 8. MyInteger is now 16. Okay, let's stop this for a second. And let's change this to, let's say, a value of 4. So I'm changing my integer, and I'm going to hit play one more time. When I do so, I'm going to see a value of 4 and now a value of 8. So it's going in and it's returning the doubled value. Let's stop this and head back into our code for a second. Okay, inside of the code, what I'd like to do is I'd like to take a look at how we can return early. So I mentioned to you before that there is a return type, and in this particular case, it is looking for an integer. Previously, I had the return at the end of the function body, and it's not necessary. You can return from any location inside of your function. You can return right away if you want. So what I'm doing here is I'm utilizing an if statement, and we're going to talk about that in our next set of videos. But I'm utilizing an if statement. For now, just understand that it takes a look at this comparison, and if it's true, it's going to do this, and if it's false, it's going to move on to the next thing. Just think of it like that for now. So what is this doing now? Instead, it's saying, okay, I'm taking an integer x, I'm checking to see if x is less than 5, and if it's less than 5, I'm going to return. It's going to return at this point in time. It's not going to ever run x is equal to x times 2. So our value in this particular case is going to be what it was before. I'm going to say file, and I'm going to say save. Once again, save. I'm going to minimize this, and I'm going to clear this out. Clear. Now, right now my integer is equal to 4, which is less than 5. I'm expecting to see my integer is 4, and now my integer is 4. So when I hit play, there we go. My integer is 4, and now my integer is 4. Okay, awesome. Let's go back to our code one more time and check out one more thing. So here we are back in the code, and the last thing I want to take a look at is the fact that I utilized my integer twice. My integer was being returned, it's being set equal to something, and I used my integer here. Now, we didn't have to. We didn't actually have to do this in any way because obviously we always have access to my integer. We didn't have to actually pass it in as a parameter because my integer is actually a value that we had available to us. But if we wanted to, we could have put any value here. So I could have put a value of, 88. And as soon as I put a value of 88 here and I file save this, it's no longer going to take a look at my integer, but it's going to say my integer is my integer. It's then going to double that value. It's going to say my integer is whatever I have it set to, 4. Then it's going to go in here with integer doubler of 88, and it's going to return 88 times 2, which is 176. So I'm going to see 176 right here for my integer. All right, let's save that, which I just did, and let's go back in here. Let's clear out and hit play. There we go. So we can see my integer is 4 and my integer value is now 176. So it was completely unnecessary for me to actually pass in that parameter. I was only doing it as a demonstration. All right, so the parameter that you're passing in, when I was passing in my integer, it was completely unnecessary to do that. If I was only working with my integer, I could have immediately accessed that value anyway because it was available in the class itself. If, however, I was using a value that wasn't immediately available within the class, I'd want to send it in as a parameter, as part of the parameter list. All right, guys, I hope that was helpful. That takes us to the end of this particular episode. I hope that was helpful, and I hope you understood it. That is our functions. We went through and talked about all of our different functions, our custom functions. We're going to be writing a lot of functions as we move forward. All right, so if you have any questions, please feel free to ask. If you're in my class, make sure you're asking about these functions if you do not understand. All right, guys, I hope you enjoyed it. If you did, let me know with a thumbs up, and if you didn't, a thumbs down is perfectly fine. If you give me a thumbs down, I'd really like it if you let me know what you don't like. If you just simply give me a thumbs down, I won't actually know what the problem is, and I am big on fixing problems, so if there's something I'm not doing right, I want to know about it. All right, guys, thumbs up. Thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.